Department of Biology, and I'm really happy to introduce Cecilia Davis. Cecilia is a new graduate student. She just began this past fall. She finished her undergraduate at Piedmont College, and she's actually going to be working on her thesis to do with land use and parasites in snails, which is something I do regularly. However, last semester in my freshwater biology class, the graduate students all worked on sort of a synthesis, a review of different papers to understand a particular topic to do with water quantity or quality at different national, regional, or international, national, regional, or local scales. And so she's going to present what her topic was about, and she did a great job in her research here. So take it away, Cece.
Thank you, Dr. DJ. Good morning, guys.
Good morning.
So, the leading cause of water quality degradation in the United States is due to non-point source pollution. And what non-point source pollution is the excess of pollutants depositing into a watershed that originate from multiple different sources. So, even with the Clean Water Act amended in 1987, agricultural non-point pollution continues to be a major concern for water quality in America. So what I wanted to do, let me backtrack. So scientists were looking for a way to decrease pollution, and in that way they developed computer simulation models in order to simulate this pollution runoff in a watershed and figure out exactly what amounts and what types of pollution there are in these different watersheds. So what I wanted to do, I looked at 50 different peer-reviewed papers that were on non-point source pollution models that ran on agricultural lands in the United States. And the main sources of agricultural non-point solutions come from crops, they come from crop management practices, and they come from livestock. These all deposit sediments, nutrients such as carbon, nitrogen, and phosphorus, as well as runoff from these herbicides, pesticides, and fertilizers. So within these 50 papers, I found out about 35% of them ran only simulations. However, 65% of them ran simulations and compared those simulations to actual observations of what they found in the watershed. And I think that ended up being the most effective, most accurate number when they compared the numbers to the actual measurements. So I looked at for each paper, I looked at which of 3 elements they had or measured best. So, and these aren't all the computer simulation models, these are the ones I found most commonly within the papers. I looked at 3 elements, sediment, nutrient, and runoff, and found which model ran the best of these 3. So I found out of those, 5 were able to run all 3 of these, or detect all 3 of these pretty well. However, most of them were only able to detect sediment and runoff. I also wanted to look at what type of simulation was run. Was it more of a short-term or a long-term effect? So the most common were short-term effects. They could simulate just single storm events. However, there were some that could do both short and long-term events and measure those pretty accurately. Lastly, I wanted to see what type of limitations were on these models. So for instance, AG, NPS, and GIS were not effective for large watersheds and heavy rainfall, and EPIC and SWOT were both sensitive to crop rotation, so you could only have one crop. It could only be a one type of crop situation for that one in order to detect the pollution more accurately. So the main object I wanted to do was kind of compile all this data together and make it easier for scientists who want to plan and improve water quality in agricultural watersheds, and kind of give them something they can look at, because it's not really a one-size-fits-all situation for these models. There are hundreds of models that are developed. And in order for them to have accurate reads, they have to be properly calibrated and spatially oriented for aspects such as topography, land use, weather patterns, and stuff like that. So I was just really hoping to have something kind of put together that people can look at and more accurately choose a model so they can predict the amounts of pollution and the type of pollution in a watershed much more easily. I think that hit it all.
Thank you.
Does anyone have questions?